How's it going, DJ Devin? Morning. All right, let's get some windows wrangled here. All right, good morning. Welcome. Happy Saturday. Looks like I've got sound good there. This is good there. All right, so welcome. For anybody that's new, my name is Tim. First of all, thanks for tuning in. If you don't know, if you haven't watched the stream before, I should say, usually what I work on is some stuff related to CircuitPython. If you don't know what that is, you can learn more at the main website, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them over here. Today I am working with this one, which is a PyPortal Titano, which is sort of like a little tablet as far as microcontrollers go. It's got a nice relatively big screen. I think it's like 2.5 or 3 inch screen there. It's got a touch overlay on it, so we can do touch inputs on it. But this is just one kind of microcontroller, and if we back out the search here, you can see there's lots of other different shapes and sizes of these microcontrollers, and all of the ones on this page can run CircuitPython, which is a thing that you can use to program your microcontrollers. You don't have to use CircuitPython with these devices. There are lots of other ways to do it, but if you choose to, then you can install CircuitPython on there, and then when you connect it up to your computer, it will typically show up like a thumb drive or a USB, storage drive. You can edit a code file on that drive, and then when you save it, the microcontroller, the actual computer that's on this little board here, will read and interpret and execute that Python code for you. So that's the high-level look at what we're doing. Today I am, like I said, in the PyPortal Titano family here, and we're gonna play with some display I/O stuff, which I haven't messed with as much lately, but that was something that I have done a lot in the past on the stream. So we're gonna get back into some display I/O stuff. As always, let's say thanks to Adafruit, which is the company that makes CircuitPython possible by paying the team who work on it. There's a team of folks who work on CircuitPython full-time and are paid by Adafruit to do so, and there are some folks like me who are paid to work on the project part-time by Adafruit. So huge thanks to them for doing that. And then if you want to help support Adafruit and CircuitPython, one of the easiest ways to do it is just head over to adafruit.com and purchase hardware from them. They have the actual microcontroller devices themselves, like the PyPortal Titano that I'm using today. Is an Adafruit device. They also have all sorts of add-on things that you can connect up with your microcontroller, or even accessories. Like this one is just an acrylic, enclosure. It's not electronic at all. This is just an add-on thing. They have all kinds of stuff like that that you can get for your microcontrollers and circuits and maker projects and stuff like that. So head over there, get yourself some toys. Thank you for doing that. Thanks to them for keeping CircuitPython going for all these years. So the next hug report that I have today, while we just continue the hug reports, the next hug report goes to Deshipu for linking me to this this concept a couple of weeks back, which is something I had seen before. I think I watched this video before, but had kind of forgotten about it. So it was nice to see that pop back up again. And I think this is something that is interesting for us because we don't necessarily have a GPU that can just do better for us. So this is a concept here. This one is a blog post talking about a way to rotate bitmaps, basically. And then this is a video that's explaining the same thing. So Stand Up Maths, for anybody that doesn't know, is this this fellow Matt Parker? I don't know if that's right. Matt something. Talks about math. He's pretty cool. If you are at all even tangentially interested in math and numbers and things like that, he's got lots of cool videos, usually breaking down one particular topic each time. In this video, he's talking about this same operation, this same idea of rotating bitmaps through these 3 shear operations. Let me duplicate this because I kind of want to keep this part of the video. But there is a part back here that makes this a little bit more clear what's going on. So there's a bitmap picture, and in this case, he's using Mario. And then it's going to get sheared. So one side is going to move one way, one half. The top half is going to move one way. The bottom half is going to move the other way. So that's the first shear. Then there's going to be another shear that's a vertical one. So it gets split in the middle, and one side goes up and one side goes down. And then there's one more horizontal one, which just goes the same as the first way again. So one side goes one way, one half, I should say, goes one way, the top half, and then the bottom half goes the other way. And with those three operations, it makes it so that Mario, or whatever bitmap you're using, looks rotated. So apparently this was a thing that was used frequently in the past in video game systems and stuff like that, from what I understand, before there were better graphics. Not only graphics that get rendered, because obviously this is a very pixelated thing, but also just better rendering techniques. Today we have many, many more pixels, and we have GPUs that can do all kinds of insane stuff to manipulate them. So this is kind of a thing that doesn't have as much practical use for modern graphics, but for display I/O, it seems like it might actually be pretty interesting, because we are in this world where we do have relatively few pixels like this for the most part. I mean, you can use whatever bitmap you want, but like there's not a whole lot of memory, so you generally are not doing, giant HD 1080p photos or anything crazy like this. So we don't have any GPU that can just handle it for us without the main computer bothering with it. We do have a way to rotate. We currently have bitmaptools.rotozoom, which is a super cool function that's like a Swiss Army knife of a function for bitmaps. It lets you rotate and or zoom and or clip, like cut a particular part out of a picture. So it can do a lot of different things, but it can take a source picture. You can take some part of the source picture, copy that into a new bitmap, and then apply some transformation, either a rotation if you want, a zoom if you want, and then of course the clipping by declaring where you cut out. You can also declare where you paste. There's all kinds of stuff that goes into here. The rotation is the part that is most related to what I'm working on today. So this does let you rotate a bitmap effectively. You could open up one bitmap, you could open up a new bitmap for it to land in, and then you could kind of rotozoom, copy that one, rotate it by X degrees, put it into the other one, and then show that rotated one on the screen. This is a thing we do have today, but I think this is using a different technique than this, so it might not be as efficient. But I'm not sure. We'll have to see once I implement it. Partially, I'm just interested in doing this to see how it goes. Partially, I'm thinking maybe this provides an alternative to rotozoom that might just work differently. Like, I think one of the things that they talk about in this video is how every pixel gets represented in the rotated one. So in the case of Mario, Mario has these two golden buttons on his overalls. And in some ways that you rotate, it's possible for those buttons to get messed up, to either become 2 pixels or to be like rounded off and become no pixels and just disappear entirely at certain rotations. And I think, I'm not positive, but I think that rotozoom might be like that. If you use that, I think small details are at risk of disappearing or becoming double or whatever in size. Whereas with this kind of rotation, this shear, every single original pixel from the original image will exist in the new image as exactly 1 pixel. So it's 1-to-1. So any single pixel details will still be represented by single pixels after the rotation. So that's an interesting property of this that's kind of cool for especially very small pixelated images. When you're using super small images like this, kind of every pixel counts usually. And in our case, like with the PyPortal here, I have it scaled additionally as well. So this is a 16 by, I think it's 16 by 16. I'm not actually sure. But I think it's 16, and then it's scaled right now to ×3. So like Blinka has, you know, single pixel there, a single pixel there, you know, a single blue pixel in her eye. There's a couple of parts like that where it is 1 pixel. So we would want that idea coming through where each of those hopefully can be represented by exactly 1. Okay, so enough yammering. Let's get to doing some coding. But that's the idea of what I'm working on. If there's any questions, ideas, comments, whatever, drop them in the chat as always. Could see this being useful for widgets. Widgets are widgets vector-based, and it wouldn't apply. I'm thinking of an arc widget like Adafruit.io uses. An arc widget. I'm not familiar specifically with the one on Adafruit.io. And there is an arc drawing thing inside of display shapes, he says, somewhat unconfidently, because he doesn't know if that's actually where it's at. Arc, yeah, there totally is. So there is an arc in here. I don't think that's definitely not the one you're talking about, because this is not Adafruit.io necessarily. I don't think, although maybe there's maybe the Adafruit.io library uses this and I don't know about it. That's possible. This one can draw arcs. We should add some pictures. I forget what they look like. I don't know. Is this like, I don't know if it's like a part of a pizza, you know, like a pie with a piece cut out. I think there's something somewhere that can draw kind of like a rainbow, basically, like a long rectangle that you curved around a thing. I don't know if that's this or not, though. And to answer, could this thing I'm interested in building be used? It could be used with this thing, because this is ultimately just a bitmap. So whatever this creates is going into a bitmap internally. So it totally could get rotated with this technique, with either technique. In fact, actually, the bitmap tools one or the new one, if and when it exists. In terms of something, if you mean like on the actual Adafruit.io page, like in the dashboard and on the server side, I don't think what I am doing will be able to affect it. The same technique could be used in JavaScript or somewhere to work on that side, but the bit here will just run on the microcontroller primarily. You can run on a PC with Blinka Display.io, but let's do this rotozoom first and see how that turns out. So we have a sprite. Let's make a rotated sprite. Well, sprite sheet. Let's make a rotated BMP for bitmap. And it needs to be at least the same size. I think it needs to be bigger, otherwise the corners might get cut off. I'm just gonna make it like double and see where we end up. So let's make it 32. That's gonna be a bitmap which gets sizes. I think it's been a minute since I've just declared a bitmap. Class bitmap doesn't know anything about it, huh? Interesting. I guess maybe we don't have stubs or display or something. These are the widgets saved for Adafruit dashboard. Okay, I get you. I remember you was working on something like this. Tumblr Ever, probably forever. Something like this for Tumblr Ever. The UI you're working with, Tumblr, or the UI you're working with. Can't remember the name. I gotcha. I did make a yeah. I think I know what you're talking about. The I don't remember the name of it either. Yeah, I found like a GUI framework that that I started building a dashboard on top of. Actually, two different dashboards. One of them that runs in the microcontroller with an HTTP server, and one of them that runs on a different, like on a PC or a Raspberry Pi or something, and the microcontroller just talks to it. Tab. I want to say tab something was in the name. Tabular maybe, or something like that. I don't know. It won't necessarily, though. The work that I'm interested in doing today won't necessarily apply to that, just because that is inside of like web in the PC, basically. And even in the case, even in the case of the microcontroller one, where the microcontroller does run the server and technically hosts the HTML page and everything, all of the actual dashboard is rendered on the client browser on the PC that's viewing it. So it's all using HTML and JavaScript, which are all totally different from display IO and doing stuff quite like this. Yeah, I'm with you there. I'd have to look back. I can't remember the exact name of it. I do think I know what you're talking about, though. I was working on that. This just does not want to fill in for some reason. I don't know why. I don't know why it doesn't want to show me this. What's the new one I learned? Control-Shift-I? Ooh, yeah, okay. It is width, height, value, count, right? Okay. I don't know if it matters if we value count. We want the number of values that's in the original, which is the length of the palette. Okay, and then we're gonna go bitmap tools. So I'm gonna do a rotozoom first so we can look at how that one comes out, and then I'll start trying to implement the new one. So that is destination bitmap. Destination bitmap, that's gonna be rotated. Then it is probably source bitmap, which is going to be sprite sheet. One thing I actually forgot about, this is coming from a sprite sheet. So we actually do need to take care to, we need to do the cutting, right? Can I like box this somehow? Oh, interesting. Okay, that's sort of helpful. Chessboard? Guessing that means transparency. I wish I could draw a box right here and measure. I'm pretty sure these are 16. 13, 14, 15. Yeah, it's got to be 16. I'm pretty sure it is. So that's going to be sprite sheet for the source. Might as well just use names on all these. Does this give me? It does. Although I don't. Okay, they are here. Okay, so X or a horizontal pixel location in the destination where source point px py defaults to none, which goes to the horizontal midway point. That sounds good to me. Vertical probably behaves the same way. None, which goes to the vertical midway point. Yep, let's do that. Let's just put it in the middle. Destination clip. The first corner of the rectangular destination clipping region that constrains the region writing into the destination bitmap. So I don't think we want these. These are if we wanted to paste but like define a box within which we don't paste outside of. In my case, though, I want to paste the whole thing. I don't want to clip it. I do want to clip, like cut. I don't want to cut the entire bitmap. But when I go to paste it, I do want to paste everything that I did cut. Source clip, that's what we're going to do. We have a PX, horizontal pixel value in the source bitmap that is placed into the destination bitmap. Defaults to none, which causes it to use the horizontal midway point. I'm not sure I understand this part, actually. So the horizontal pixel location in the source bitmap. Okay, I guess that just means we're gonna center it within the output. We want to center the input within the output. We want to line up the center of the part that's cut with the place where we're pasting. So I guess we'll leave that default. Pasting a shared bitmap might not have the same. Yes, totally true. We are going to have to make a bigger bitmap. When it comes time to do the shearing, we're going to have to make the destination bitmap is going to have to be bigger by a certain amount. Or option B, you can keep it the same size, but you might lose pixels on the corners, on the really, I guess, the what were the corners and what become the middle of the edges. But I think by default, I'll make it so that it goes to a bigger bitmap. And we'll do so once we do the calculation to figure out how far we're going to shear. Then we'll use that number to know how much bigger we have to make the destination bitmap. Might overshoot though. I don't know if I know the exact formula, but we'll get to that at some point. So source clip, first corner of the rectangular. So we definitely want to do this. So our source clip starts at the top left corner of the entire sprite sheet. So 0, 0. And then source clip 1, the second corner of the rectangular source clipping. I don't know if it's inclusive or exclusive, but that should be 15, 15, because we want to cut a 16 pixel chunk. That's if it's inclusive. We'll see if we are missing pixel or not. Angle of rotation. Let's start with just this and see if this works. Okay, so let's not add sprite to main group. Let's go and make a rotated tile grid. That's going to be using the rotated bitmap. Pixel shader is going to be the same, so palette width is 1 by 1. Because that's width and height in tiles. Tile width, that is 16. No. That's going to be the size of the bitmap, however, which is 32, I guess, actually. But let me make this rotated bmp.width. Let's just do that. That way, when we change it later, it'll just adjust itself. Okay. Default tile. I don't know if we need that one, but I'll put it. I'm pretty sure we don't need that one, honestly. Let's get rid of it. This has been happening. I'm gonna try a new chord. Okay, I think that cable is crapping out on me. I'm gonna hope that cable is crapping out on me. Because the alternative is like perhaps the pi portal itself, which is not good. That was happening to me before where it was not letting me save. And I already did, I reformatted this drive just the other day. This is why it's almost empty. Okay, so that did let me save. Hopefully, it'll just be good with the new chord. Okay, I never put the new tile grid onto the main group, so therefore it didn't get shown. Let's do that. Should I turn auto reload back on? Interesting, it's still not showing. It says those are unfilled, but it also, a bunch of them say defaults too. Unclear to me then, like, do I have to pass them, or? We're gonna make a thing to print bitmaps so that I can see if it's just all zeros or what. This will be helpful when we start shearing anyway, because we're gonna need to be looking at very closely what's going on inside of our bitmap. I think that it's actually YX. I'm positive, I guess. We're going to print the number of the pixel. We're going to print a comma. And let's go no space and see how that works. But I want to do, is end char, is it end equals, I want to do no new line. We print a row at a time. And then the end of the row we print a new line. I don't know if we actually, I think we probably don't need that. I think we can just do print. I almost want to go cut the castle, cut the Blinka out of that so that we can have a smaller one. Maybe my source clip is not actually working. Or maybe the PX being, maybe I need to set the PX to be the middle of Blinka. That's probably it. Okay, so after we roto zoom, let's do a print bitmap. Let's see if that even works. All right, it's not fast, but it does work. probably would, honestly, it would probably go faster if we did it after we set the root group to main group. So after it's already showing display IO, because then it won't need to like bother updating the display with all of this. Yeah, we didn't even get to see it because it was so fast. I can blast it out real fast. Okay, that's definitely how we want to do that. Okay, so it definitely doesn't have any data in it. Let's try the PX or whatever. What was that? Pretty sure that was PX for the horizontal pixel location in the source bitmap that's placed into the destination bitmap at OXOY, which is the middle for us. So we want basically the middle of Blinka, which is tough because Blinka is 16 by 16, which is even and therefore doesn't have an exact middle. A full screen image, like the image of the shifting. Oh, it totally works on big images too. We probably don't have enough horsepower on CircuitPython to do it, but in this video, there's actually a bunch of sections of the video where he is rotated. And even at the end, he rotates all the way around. And that was like in the actual footage for the YouTube video, which is 1080p. So it's not fast, but you totally can do it on big images as well. So I guess let's just put 7.7. Ah, okay, now we have some stuff in there. Okay, we have Blinka. Blinka's moved over a little bit, but otherwise basically the same, it looks like. Let me try showing the original also. And let's move the rotated one further to the right. Just 50. That's a bit far, truthfully. Forgot we're scaled, so it's like 50 actually equals 150. Okay. It does look like the bottom row was cut off. So that must be exclusive. Therefore, we need 16s here, probably. There we go. Now we got Blinka's tail and everything. Did the left edge get cut off? It almost looks like maybe the left edge got cut off. No, I don't think so, actually. No. Yeah, that's good. Okay. Okay. So now we could try angle, which is in radians or degrees. Angle of rotation in radians, positive is clockwise, defaults to none, which gets treated as 0 radians or no rotations. I do not know radians to degrees off the top of my head. So what if we wanted to try rotating by 45 degrees? That would be this many radians. Nice. Okay, so yeah, the It's not bad, honestly. It's not too bad, but there is some weirdness, like the tongue has become 2 pixels. The blue of the eye has actually fallen out of the eye's sort of square, but it's kind of just how the square is going to be at this size. Yeah, pretty good, honestly. Really, the tongue is the part that is easiest, or the tail there maybe. Also looks like it's become 2. But otherwise, that's actually not too bad. Let's try one more, maybe like a 25 or something. Yeah, so in that one, the tongue is now disconnected from Blinka's head, which I'm not sure if our technique will suffer from that same problem or not, maybe. Okay. Anyway, so this is the current way that we can rotate with RotoZoom. I would like to start this probably by just making a def shear rotate. That's going to accept a bitmap and a angle. Actually, one more one that I'm curious about is, what does 90 look like? Of this left dangling function there. Okay. 90 gets a little weird on the base there. What was the base actually gets sort of angled down a tiny bit, I guess. Maybe that's because of the rounding. I don't know. That's all right. It'll be interesting to compare, because I don't actually know what technique RotoZoom is using, and I probably wouldn't understand the C code if I dove into it without like taking a really, really, really long time to pick through it and really like add a bunch of prints and touch a bunch of pixels, basically. Wonder how well. Yeah. Okay. Okay, let's try this. So shear rotate's going to take the bitmap and the angle. The one way that you can describe this process is with these matrices, which actually does make it pretty clear, to me at least, how this is working. So we start with an XY coordinate, which they're choosing to visualize as a matrix. We are changing it by adding some value A, which is multiplied by Y, so how far up or down you are. So it shears further away, the further away from the center point you are. And then to know which value to use for A, there's all 3 are here. You go horizontal by A amount, then you go vertical This one is now operating on Y instead of X. You go vertical on the B amount, and you go horizontal again on the C amount, and then they go through this whole proof here, basically, that proves that A and C are the same values, which is over my head, truthfully. I'll take his word for it. But it goes on to show here how to get the numbers for the skew. So for the horizontal skews, it is negative tan times the angle over 2. And I'm going to assume that that is probably the angle in radians as well, but I don't know. So how do we do tan? Do you need ULab for that, or can you do that with, is there import math? Atan. Tan, we have tan, okay. Well, but our skew is different for each row. Horizontal skews. So conveniently, he's actually working with a 16 by 16 here as well. How far angle to tan? So there, he's using a 30-degree angle, and it does get over 2. I wish I could almost like drop pinpoints at different parts of the video. So there's angle over 2. So he's actually using degrees though, not radians, because he did 30 degrees and then he said 30 over 2 is 15. Did he multiply though? He did multiply. Okay. So we figure this out, and then we multiply it by the, what I'll call the index of the row, but it's the index where the middle of the picture is 0, the top is positive, the bottom is negative. Index is probably not the proper term, but centered index maybe. Okay, so I'm going to call this horizontal shear a multiplier. But I'm going to shorten that to H shear multiplier, or even just H multiplier, I think. So the H multiplier is negative math.tan the angle over 2. And then the vertical is the sine of the angle. So V multiplier equals math.sine of angle. So then we're basically going to multiply these by the index of the row or column. And how do we figure that out? So we need to know the midway point. So I'm going to say h midway is equal to bitmap width over 2, and we want that to be an integer division because we can't do half pixels. Then a v midway equals bmp dot height over 2. So in order to go from, so we're going to basically end up looping over all the pixels in here. Or looping over all the rows if you want to think of it, but we're going to loop over pixels within the row too. We're going to need to be multiplying that number. So we need to offset the actual x and y coordinates inside of our bitmap against the midways. Okay, so let's try for row in, let's say row index in range bitmap height. So for each row in the bitmap, let's just print out row index. That's going to start on 0. We want it to be positive. So that's going to be basically the midway point, but it might need to be like row index 0. So midway point minus row index? I think it's midway point minus row index. Horizontal midway minus the row index. So on the first one, the row index is 0, the horizontal midway is 8. So 8 minus 0 is 8. On the next one then, that's still 8. So 8 minus 1 is 7. So that's going to count us down to 0. 0 is the actual midway row that we're treating it as. And then once we pass that, once we get to row indexes bigger than 8, we start going negative. Yeah, I think that's what we want. Let's just print row index, and then just make sure these numbers come out right. After we actually close the string. Let me not do the roto zoom for now, I think. However, if we don't do the roto zoom, we're actually going to be looking at a 16 by, well, a 32 by 32. Let me make one of these that's just, or let me just do this, I guess. I want one of these that's 16 by 16 and doesn't get rotated, but does still get the thing put into it. Didn't work. Well, it didn't work because we didn't roto zoom it, obviously. We want to roto zoom it, but we just want to know angle on it. Is it one lower? It's okay. We lost the bottom again. Maybe this should have been 6. No. Okay. 7. So did I go the wrong way? You're supposed to go to 8? I guess maybe we were supposed to go to 8. Was I on 8 before? 8 feels wrong because they're indexes, though. Okay. So we have what we call rotated bitmap. It's not actually rotated anymore, but I want to go and pass that into my shear function. And I'm just going to give it kind of an arbitrary angle, I guess. We'll do 30 just like he did, I suppose. That makes my numbers basically the same, which is convenient. Sweet. Okay, yep, that's exactly what we want. We start at 8. We go down to our mid row, which is 0. And then we continue on negative and we make it to -7. And basically the mid row is offset by 1 because it's an even total number of pixels. So that is what we're going to be multiplying by the multiplier. This value, which we will call what? Let's call this the centered row index. I don't know if that's the best name, but I'll go with that until I come up with something better. Centered row index is going to be that. So then we're going to be multiplying that centered row index by the multiplier, the H multiplier. Make sure we get numbers here that are reasonably close. And that we can... Ooh, those are very different. We will eventually want to truncate this too. We need to multiply each of those tan of half of our angle, tan of 15. Maybe what he actually... No, but it's different per row, so he had to have done the result. What is the tan of 15? Does tan expect radians? Maybe that's... Return the arc tangent of Oh, that's a tan. Return the tangent of x in radians. Oh, wait, return the tangent of x radians. Not in radians, just radians. Okay, so what is, we need this one again. So 30 degrees is 0.52 radians. Blah, blah, 5235, whatever. I guess let's just say then that you have to pass the angle as radians. So instead of 30 here, let's write... Actually, let me keep it. Actually, I think it would be nice to support degrees as well. Let's call it this for now, though. Okay, there we go. That looks better. Okay. So then we need to, do we want to round or just truncate? Didn't actually go through all of them, but he said round to the nearest. And, well, okay, but he was 2.1 there. He hasn't done the bottom half yet. Really what we want to know is, does the bottom one go by 2 or 1? Bottom one went by 2. Bottom one went by 2. Okay, so he did round to the nearest, which is what he said. Okay. Is there a simple way to do that? Or do I need to just like add 0.5 or whatever? Python round to the round decimal to the nearest whole. Round. Fix a number and an optional second argument to specify the number of decimal places. Round 1.87. Nice. Cool. Okay, that's what we want. Oh. Technically, I'm backwards from him. So my rotation would be 30 degrees to the counterclockwise, whereas his would be clockwise. I don't know why we ended up... Maybe... So I copied it from this one back here, and he was confused at this point. He was like... He said one of these is negative and the other one's not. And I assumed the one that got written on the screen was... Oh, okay. No, he just says whichever way you want to rotate. Okay. So that's how you decide, basically, which way you're going to rotate. So... Right. Okay. So let's just say... Let's say any positive value here is clockwise, and any negative value but then do you still use, are you allowed to have negative radians? Is that a thing, or does that not exist? That seems fine. That is weird to me, that you use a negative on the tan and a positive on the sine to rotate one way, and a positive on the tan and a negative on the sine to rotate the other way. But you're passing an angle, and the angle can be negative. How come just the angle being negative doesn't make it rotate the other way? And do we need to absolute value the angle? So if the user gave us a negative angle, do we need to absolute value it, but then use the correct ones of those? Can you make it? I take it you can round. Yeah, you can. I did one of those a minute ago and it worked. Round -187 came out to 2. Okay. So technically right now mine is trying to go counterclockwise. So I guess if anything, I want to switch it. I want when you use, because I passed a positive radians. So I would like that to represent a clockwise rotation. And in order to do that, we are going to say clockwise is equal to angle greater than 0. So if the angle is greater than 0, we're moving clockwise. Otherwise, we are moving anti-clockwise, or counterclockwise, as I would normally say. And then we need to account for this here by I'm just gonna do this. If clockwise, we're gonna put these in here. We're gonna switch them because we found out that that's actually going the other way. And we're just gonna do an else, put them the other way. There's a bunch of ways you could write this. There's probably one that's better than this, I'm not sure, but this is the way that makes the most sense in my head because it's like very clear about what's happening. If we're clockwise, they get declared that way. Else, it's counterclockwise, they get declared that way. Probably we could do it somehow where we don't have to like declare them twice in there. We could maybe just declare them once and then change it or something. I don't know, but let's keep it this way for now. Okay. So that's going to do that. So let's make sure then that we are going the right way now. I'm just going to run that again. We should have positive on the top, negative on the bottom. Very good, very good. Let's round those. Round. Let's actually get this thrown into a variable. Let's call this what? Let's call this the offset amount. Or maybe we should call it the shear amount for this row. But I guess that's implied because we're inside the for loop for rows. So the shear amount for this row is equal to rounding this, which I'm going to cut and put into here. And then we'll take this variable and put that there. Sweet. Okay, those are rounded. So I think so I'm going to just do one shear at a time here. I'm not going to worry about what's going to happen when we bring the second shear that's vertical and all that. Anti-clockwise is more popular, yeah. Counterclockwise is more American, at least as I've found. Yeah. I think that follows my my experience as well, I think. All right, so in our case, so the 2 actually then is going to represent how much bigger our bitmap needs to be. The maximum value of this, well, the maximum of the absolute value, because maybe if this was -3 or something, then we would need to be 3 bigger. So let's say we call this padding or margin, or do we just call this something else? Max offset amount. I'm going to call it padding size. But I'm going to call it H padding size. And it's going to start on 0. And as we loop through these rows, it's going to say if H padding size is less than the absolute value of the shear amount, we are going to set the H padding size to the shear amount, the absolute value of it. So the biggest one is going to end up there. And that H padding size, we need our new bitmap to be that many pixels bigger than our original. So new bitmap equals a bitmap, which is the original bitmap width plus, we actually need times 2 because we need that many pixels on the left and we need that many pixels on the right. So BMP width plus the H padding size times 2. That's the width. Height is, I'm just going to actually set it to the same for right now, but once we do the second shear, we're going to have a very similar thing going on here with that. We'll just say height. And then the number of colors is the same. Ooh. You know what's weird in display.io? On-disk bitmap has a dot pixel shader, which is basically a reference to its palette, but bitmap doesn't. Bitmap, once it's in a tile grid, then it has a reference to its palette. I'm going to pass the palette in here. I guess I don't think that that's maybe the best way, but the length of the palette, that's how many colors, that's our new bitmap. Okay. So with this one, we know that our padding size was 2, so we know that this should be generating 4 pixels bigger, so it should be 20 by 16. by 16 is what we're thinking that should come out to. I didn't pass the palette. I've always noticed that too. It's confused me, which needs the pixel shader and why it wants the palette. I always have to look it up. It would be nice if there's an easy way to make them both uniform. Yeah, I think that I mean, it's tough because it would be such a drastic change for bitmap at this point, but I do think it would be nice if bitmap had a dot palette or a dot pixel shader that you could access. But the thing is, like, currently it can exist separately. So it gets weird to link them together a little bit. Okay, 20 by 16 we did get perfect. So yeah, let's try to actually apply the shear now. So we have, well, so one thing that's a bit weird is I wonder if does it depend on the angle? Is it safe to say that however far we moved the first row to the right, the last row is always going to be the same? Or is there some situation where the top, let's say, could move by, 3 pixels, and the bottom could be moving left by 4 pixels? Is there any angle where that's the case? Or is it always the same? Because basically what I'm getting at is, if the first row is always guaranteed to be shifting by the maximum amount, then we don't need to bother with this logic of like, if the shear amount is bigger than that, then set the new one. Instead, we could just look at the first row and then know the size and then make the new one based on it, which would save us from having to loop through this twice. I'm going to work under the assumption that it is, because I feel like it should be, because it's the midway point. Like, it feels like maybe there could be an angle that's like steeper that would make that not the case, but we're always using the midway point, and for an even-sized bitmap, which is what we actually have, we are actually using the lower side of the midway point, which means the top is bigger by 1 pixel, which means the top should always be exaggerated further than the bottom on an even-sized one if we always choose the bottom half of the center. I think that this should be fine. I think we should be able to just look at the first row, find this out, and then not bother needing to know the rest of them. So let's calculate the shear amount for the first row. First row centered index is h midway minus 0. That's dumb to have a minus 0, but I'm going to keep it just because it's like makes it a little bit more self-documenting. Row index, so that's 0. So that's, now we want the first row shear amount. You can just calculate that the same way, except for that's now this. Okay, and now we can create the bitmap before we loop, which is nice because while we're looping, we can be putting stuff into the new bitmap. And we could do this 1 pixel at a time, technically. Like, we could take the first pixel, move it over 2, and then take the next one, move it over 2, move it over 2. Like, we could do that. But we actually could use, well, we could use rota. Oh, so not what I want to do. None of these are at the timestamp they were anymore. Nice. Oh well. What was I doing before I got distracted by closing that accidentally? Oh, I want to go to the docs because I want to find Bitmap Tools has split, which will let us copy a whole row at a time. All right, I gotta run to the restroom real fast though, so I will be back in a minute, and we'll do that. issue I'm thinking of is tile grid has to match some dimensions divisible by pixels, but in order to rotate the center, in order to rotate by center, the optimal image size would be an odd number. Yeah, that's definitely true. Yeah, that's what I was, where like with the Minecraft sword is the easiest way to see this. But basically that's what I was saying, the center there, because it's even, we're using the bottom half of the center. So technically we're like below the center a little bit, but it's because the center is actually a line between pixels instead of a pixel. So yeah, an odd sized bitmap would actually be the ideal candidate for this, because then you would have a literal center pixel that you would be like actually rotating around that one pixel. Okay, so as we do this, we are gonna basically blit the entire row of the input image into the output image at the same vertical row. This light is going crazy on me. I'm assuming this is dead. Actually not, which is really weird. The light on this keeps blinking. If it keeps doing it, I'm probably gonna turn it off. Let me try just talk. Yes. Got some ghosts over here. You know what I didn't do today for some reason is open up the Twitch chat. Also, we got a follow on Twitch. Hey, Boss Gans over on Twitch. Appreciate the follow, my friend. Sorry, I'm a little low on the, little slow, I should say, on the uptake there. About 45 minutes ago, we got a follow. Appreciate that, my friend. I don't know if you're still around, but if so, cheers and thanks for watching. Okay, so we have our new bitmap. We want to call bitmap tools split. I'm gonna make this full for now. We don't really need to see anything just yet. So we're gonna blit. I don't know that off the top of my head. I actually have the docs over here though, which is what I'm gonna get next. But so that goes destination, then source, then XY in the source. Yeah, no, but yeah. This should say target, I think. Destination. XY, the horizontal pixel location, it says in bitmap, but I think it means in the destination bitmap where the source bitmap's upper left corner will be placed. So that's the place where we're pasting to. And then we're going to be using that to specify our rectangle, which is going to be a row. Technically, you could make this more efficient by blitting every row that has the same shear amount all in one operation. I'll save that optimization for later. So we have destination bitmap, that's going to be new bitmap. We have source, which is going to be bitmap, the one that we were passed. XY. So Y is going to stay the same, but X is going to be X is going to be 0 plus the shear amount. We don't really need to specify 0, so that's just the shear amount of this row, basically. Y is the Y that we're on, which is the row index. And we're back to being 0, 0 top left here. We're not considering the center when we're doing this one. Okay. So x1, y1, this is the minimum value to be copied from the source. So that's going to be, that is going to be, so x1 is going to be 0. And y1 is going to be row index. So basically, we always start at the left pixel, but we're going down the bitmap as row index increases. Then our x2, y2. So x2 is going to be maximum x exclusive. So that's going to be the width of the input image all the way the other side, and that's exclusive. So we're going to go one bigger than the actual index of the pixel, which means we can use width by itself. Let's new line these. Let's go xy alone, and then x1, y1 alone. Then we'll go x2, y2 alone as well. Y2. So that's going to be, we're always going to go by one pixel here. So we'll just go row index plus 1. And that's also exclusive. So when we're going to end up with 1 past the end, but that's okay. What's wrong with that? Keyword repeated? Oh, y2. Skip source, skip dest, we can leave those because we just want to copy everything. Okay. That should loop through the rows and apply the first shear of our rotation. Let me just return BMP. Let's say shear rotated BMP equals. Then let's make a tile grid for it. It's going to use the shear rotated 1 by 1. Tile width is the width of the image. Palette stays the same. Okay. Main group dot append the shear rotated tile grid. Let's also do a shear rotated tile grid dot x equals, we did 20 before, so let's say 40. Move it out a bit further as well. $46. Missing one required positional argument. Oh, sort. It looks like, so the star, I think we can't actually use names on these. That's weird to me that there's some variables that you're not allowed to use their name like that. Okay, this time we got x must be 0 to 16. CircuitPython line 46. So let's print the values that we're trying to pass to blit. Blit, vals. We can skip the bitmaps. The shear amount. Row index, that's XY. Let me put names, I guess. Actually, we don't have the ones. That's hard-coded to 0. Row index +1. I mean, you would think from the error message it's talking about the x parameter because it says x must be, but I don't know if that means possibly one of those or just literal x. Oh, right. Let me think about this. We actually need to do something different here. We need to be going further. We actually want to offset everything by the maximum shear amount because we're going from a 16 by 16 and we're going into a 20 by 16, and we want to have, like, if we didn't apply the shear, our 16 by 16 would be centered in that 20 by 20, so there'd be 2 empty columns of pixels on either side. So the place where we paste 2 actually needs to be the current shear amount, yes, but we also want to add the maximum shear amount. I made this wrong. Yeah, that should be the first row shear amount. Let's put that so we make sure that's actually the right size. So we should always be doing first row shear amount plus the shear amount. So that if shear amount is 0, we are still actually moving over by 2, which is going to get that centering effect. This is also going to make this not be out of range anymore. I don't think it's any different. Maybe it is. Let's zoom it more. Maybe we should choose a bigger angle also. Where's the scale of main group? Main. Here. I don't think it's different. I think it's the same. Okay, let's make sure that I actually got the right tile grid and bitmap and everything. So yeah, I'm returning the wrong. I returned BMP, which is my input bitmap. I actually need to be returning the one we created, the output bitmap. Let me call this, let me rename this actually to output BMP. There we go. Okay, now we're looking. So now Blinka has been sheared. Which basically pushed Blinka's top half to the right and her bottom half to the left. Okay. So now we want to do the first vertical shear. Watching you is like watching display of a magician. What would take me weeks to figure out takes you an afternoon. I love watching you work on display. Oh, nice. Glad to hear that. Hello, sorry for bothering you. Offer promotion, no. So the vertical one, I guess we effectively do the same way. And to start with, we'll need to calculate, well, we have the multiplier, but we'll need to calculate the maximum shear amount, which I'm calling the first row shear amount, which should work the same way as horizontal, where I'm pretty sure we're guaranteed that that's the biggest one, I think. Like at least matching the biggest one. So let's call this first call centered index. That's the V midway. First call shear amount. That's going to be the first call centered index plus the V times, actually, the V multiplier. Now that we have the first column shear amount, we can actually create the bitmap to be big enough with that. So the height is going to be plus the first column shear amount times 2, same way we did before. I'm pretty sure with this image, that's going to result in a 20 by 20. And we're also then going to want to be adding to our Y in our blit the shear amount, so the maximum Y shear amount, so that it gets pushed down, solve the same centering problem. Oh, new bitmap size should not be 20 by 8. So this is coming out negative. Oh, you know what I don't know about is... Well, no, we know about this should be positive or negative depending on which way we are rotating. Fine. We have the wrong way? Because that's, I mean, that should be 16, and then we would expect that we're coming up with 2. 2 times 2 is 4. But maybe it's not? Unfortunately, he didn't show the math on the vertical one either. So it's going to be tougher to know if we're correct. Let's print those. We're also printing the first column shear amount. I mean, my assumption is that's coming out to -8, right? Because we're ending up with 16 plus something equals, we're getting only 8 instead of... Maybe we have a wrong... We have a wrong sign somewhere? Should we have a negative on something? The multipliers seem okay, but the first column shear amount came out to -4. Maybe we need to we would need to absolute value that for sure. If it's negative, we want to get it back to positive. But why? It shouldn't be 4 either, though. It should be 2. 4 is the total size we want to be ending up with, because we're timesing by 2, but the actual shear amount (30 degrees). And maybe it should be 4. Be 4? I don't think it... He did just say these numbers are a little bit bigger. Okay, so what he was explaining there, he actually did it the wrong way. He went up on the right. He went up on the right, but he should have gone down on the right. $13.48. Maybe 4 is not wrong. Maybe I should have used 45 degrees. instead of 30 degrees. I really wish he would have shown this set of numbers for the vertical one, even if just once. Okay, well, let's do an absolute value and then let's run through and print the shear amounts and see what we end up with. See if it's even remotely making sense or not. So we want to get this to be absolute value of that. So now we should, I was expecting 20 by 20, but it sounds like we're going to end up with 20 by 22. By 24, I mean. Figure out my times 2. Yeah, I don't know for sure if that's right, but I guess we'll find out. So for our vertical shear, first horizontal shear, call index in range emp.width. Pretty much a lot of this can be the same. Centered row index, so we're gonna have centered call index is the v midway minus the call index. The shear amount. Okay, so he originally accidentally went up on the right side, but he was actually supposed to go down on the right side and up on the left side. And up on the left side is negative, so it does make sense actually that we got that negative number there. Okay. And we do not want to absolute value it here because we want the negative. But one thing we do need to do, even in the horizontal shear, now that we've made our bitmap bigger, we should add this to the Y where we put our blitz, where we paste is the way I think of it. Let's make sure that doesn't break anything. Just have an extra loop there that's not actually doing anything. Okay. Yeah, that looks, I think, the same as it did before. Thing is, it's moved down now, but nothing is broken. We're not missing any rows or columns that I can tell. Color box. Oops. I'm gonna stick with mine for the moment, just because I also have because I'm using the sprite sheet, That would change the way that I'm pulling it out of there. I will eventually test it on this one though, thank you, because that one will definitely make it a lot easier to know. Just like eyeballing the rotations to see if they worked right, I think. So definitely try it with that one. Let's see, where are we at here? So we moved that down. Okay, so we're ready for this. So our shear amount is, actually calculated it up here. Absolute valued it. Round the centered call index times the V multiplier. And then we don't actually need this. In fact, I don't even think any of the code is using this anymore. Yeah. Ended up doing away with that and just calculating it ahead of time and assuming the first column and row moved the farthest. Hopefully that turns out true. I think it should, but. Alright, so we'll say the call index, centered call index, and the shear amount. That will print those values for us. Alright, so column 0 goes up by 4, 3, 2, 2, 2, 1, 0, 0, 0, 1, 2, 2, 2, 3, 4. Okay, I mean, that looks good to me, and that's going to be up on the left, down on the right. Now, what do you think about this? Okay. The one thing that's different this time is in this one we were blitting from the source bitmap into the output bitmap. This time around though, we're actually not going to be doing that. We're going to be going from and to the same one. So we want to take some pixels from a spot in this bitmap and move them to a new spot in this same bitmap. So destination is going to be output and source is also going to be output. XY, the location where we're going to paste. So the X is going to stay the same, and that is going to be the call index plus the first row shear amount. So that's X, and then Y, place where we're going to paste. First row call shear amount plus the shear amount, which we calculated for this row. Column, actually, it's a column. X1 equals, I'm going to fill these in and then go back. My fingers don't like this pattern very well. Like, letter number equals number, comma, space, letter number equals... I didn't even do it correctly. For whatever reason, that's like really challenging for me to type correctly. Especially if I'm trying to put the values in. Okay, so the x1. So this is the... So this is the rectangle that we're cutting. So x1 is going to be the call index. y1 is going to be 0 because we want to get... No, it's going to be not 0 because our thing is bigger. It's going to be down by the first call shear amount, I think. Boy, I'm getting lost in the pixels here. Call index, first call shear amount, which should be the top of the actual visual part of our picture. So x2, this one should be call index plus 1. That one's actually easy. y2 should be... We actually had width here. I wonder if that should be width plus... Should that be width plus the first row shear amount? Well, it shouldn't because this one doesn't actually have the shear amount in the source, whereas this one does. Okay. So basically we want the y1 plus the original height. Okay, yeah, I have no idea if that'll work, but let's see what it does. Not good. All right, let's go ahead and do this thing here where we're going to put all the values that we're passing. I almost want to I think I'm going to declare x1, y1, x2, y2 as variables so that we can print them. Yeah. Yeah, I almost, for a minute there, I almost wished that I cut the bitmap out of the sprite sheet, but Made it this far, so we might as well forge ahead. Okay, so this is just... Yeah, I guess I'm even gonna go and make an x equals... This way we can really have variables on all of these, and we can print them all out with their actual name. Doing near as much math in here. And we can duplicate this print statement now. Okay. I think I'm gonna go ahead and do this up here as well. Okay. Let's make this easier. Okay. So y I think is wrong here. Because our y should have been... No, that's right, actually. Yeah. -4, but we're starting at 4, so we're coming up to 0. So that's actually okay, I think. Then the top left corner... Oh... 0, 4. The 1. That says 124, but that's wrong. Our box should only be 16 tall. So y2 minus y1 should be 16. Oh, this should not be centered index. This should be shear amount. Okay. different. Still not correct. I almost want to just go only apply the blit on the first one so that we can see just one operation and try to get a better idea for what it did. I think the X might be wrong somehow, because it almost looks like the tail, right? It almost looks like there's something different went on here, which is in by a couple of pixels from the left, so we shouldn't have touched that on the first column, I don't think. Let's make that -1 so we're not going to blit anything. Yeah. Somehow our X is messed up, because we shouldn't have been touching those pixels in from there yet. Okay. I will use this because that's a full, there's no transparency, so this will make it easier. Just gonna call this shear rotate blinka. Keep that. I am gonna run to the restroom again, so I'll be back in a minute. I wonder if it's not really made blit with the idea of using the same bitmap and potentially intersecting the rectangle that you're cutting. I'm wondering if maybe this is like taking one pixel, putting it somewhere, and then taking the next pixel but accidentally grabbing one that's already been changed. I think we actually might need a buffer to put these pixels into with our blit operation and then blit them back from the buffer to the thing. Because we don't want one of our individual pixel move operations to affect a future one at all. We want to cut the entire row and shift the entire thing. And I think maybe the way that we are using the same one here actually won't work. So I'm going to create a vertical slice buffer BMP. That is going to have a width of 1. That is going to have a height of output bitmap dot height, and it's going to have a length of palette number of colors. And then we are going to split from output bitmap into destination is first, actually. So from output bitmap into the buffer one, vertical slice buffer. So that represents a single column. We take it out of our real one, we put it into our buffer one, and then we go back and blit our buffer one into our real one so that we can never be trampling on the same pixels. Unfortunately, it does mean that we need 2 blits, though. And then X and Y would always be 0 to go into the vertical slice buffer. And then when we want to go back into that, we're going to go to the output from the vertical slice buffer. I'm not positive this is going to make a difference. I probably am not explaining it in a way that makes very much sense either, but basically I think it's like almost recursively like trampling on itself, basically. Maybe it's because I know internally it's going 1 pixel at a time. So like it's going to move 1 pixel and it's going to try to move the next and the next and the next and the next, but because the region we're taking from overlaps the region we're putting into, I'm thinking like we might accidentally grab a pixel that's already been done or whatever. So it's kind of like getting recursive on itself in a way. So I'm going to switch to the square at some point as well, but let me try. Let's see how this ends up behaving. And again, we do have this, only the first column is getting done, so it's still wrong, definitely, because it's still doing anything with a column that's not the first one, which it shouldn't be. Let's think about this a bit. Can I draw rect? Unfortunate that my palette, I can't just easily add a color to the palette. I wish I could see what's going on more visually. Region. Okay. I think I could use fill region to try to see what's happening. So index 4 is red, and red is not used on Blinka. So I'm going to draw rect the piece that I'm trying to blit instead of blitting it, so that visually I can look at it and see, is that the rectangle that I'm expecting it to be? My guess is no. It's also called fill region, not draw rect, but we're gonna draw into the output bitmap. And this one's weird though, because it takes x1, y1, x2, y2. Okay, let's just do that. X1, yeah. We pass those in the same. Because we're not worried about x and y. We're not worried about... Yeah. So we're not worried about where we're going to put it just yet. Let's worry about only where we're going to take it from. Value is going to be 4 because that is red in our palette. Okay. That looks fine. So, the place where we paste it. So the place where we paste it, I'm gonna just do another fill region. Or is there a draw pixel? I mean, I could just... I need bitmap tools for that, I guess. Let's just say output bitmap. I think that's got to be Y. X. Is there a draw pixel? Polygon. Let me just use fill region. I don't want to flip X and Y in my head, and I'm already very lost in the geometry here. I'd rather do as little trying to keep in mind certain bits like that as possible. So output, so then this time we're going to do x, y, and then we're just going to do x plus 1, y plus 1, because I only want to paint one pixel. And let's paint it white for now, which is 17. Okay. So that is too far to the right. The place where we should be trying to paste that is in the same column as the red. Now, one thing I can't tell is that 2 columns over, or is it 1 column over? Let's make it taller by just saying y plus 6 so that we can see which column it is. Okay, it's 2 columns over. There's an empty space between. So we're off by x positive of 2 for some reason. X is too positive, too big. And x is literally what? 2. Should it just be call index? I guess it should just be call index. Okay, now the red and the white actually look correct, I think. I'm going to comment those, and I'm going to put these back. Should we try the one that's going from and to itself? I almost wish I would have kept that. Let's do the buffer first. It feels too far up. Let's let it do more. Let's let it do more of these. Just say greater equals. Two must be 1 minus 1. Okay, well, we've messed up something else with the slice buffer. Down here, I'm pretty sure that would just always be 1. Like, actually, this would always be 0 and 1. In fact, because it's using the slice buffer, wait. Oh boy. Yeah, this would be, if it uses the buffer, then it's always just the entire buffer. Honestly, I wish we could just, can we just leave those off? If we just leave those off? Hmm. That might be correct. I know the head has gotten all messed up here. The eye in particular is, we've got an extra eye going on, kind of. I mean, it can't actually be correct, though, because we're not one-to-one on our pixels, right? Like, our eye is suddenly got more going on there. Probably we're supposed to be covering up some part. So, I mean, we were supposed to move the right side down. I bet... Yeah, so technically we copy-pasted a column. We copied a column, and then we pasted it, in this case, higher, lower. Really what we need to do, though, is cut. We need to cut. We want to get rid of the old visual information where it was. We want to move it, physically move it, so that it's no longer in its old place, and now it's only in its new place. But instead, we're making a duplicate, we're making a copy of it, and moving the copy, and leaving the original. And in order to get rid of the original in our context, we need to basically cover it up. We need to erase it, and the way we're going to erase it is by setting it to transparency index, which is 0. Which is actually convenient. We can use this to do that. So after we put it into the vertical slice buffer, erase original column. Erase column in full BMP. I don't know the best way to phrase it, but so that's going to be everything we turned red. So we're just going to do 0 instead of 4. Nice. Okay. So I think that is a correct second shear. I think that's a correct vertical shear. Another thing that might have been good to do is actually make that Mario, that I could test with the real Mario. Is the pink transparent still valid after the blit? Yes. Although it's green in my case, not pink, but it will still be transparent after the blit. Because basically what it is any pixel in the bitmap that has a 0 for its color index value will get painted green, and green is set to transparent currently. And then even after the blit, it's just going to blit the 0 from one spot to another, but it's using the same palette, so the 0 is still transparent. Okay, so here we would need to apply the third transformation, the third shear, which is actually technically the same as the first one. But unfortunately for us, we can't really just copy paste the first one because my first one is going from the source bitmap into the output bitmap. Really what we want to be doing is another thing basically like this, where we need to, we're taking it out of and putting it into the same bitmap. Although for purposes of just being easier, I did end up making a temporary buffer to put it into in the middle. Yeah, I like pink as well sometimes. I see pink used a lot. In this case, the heart actually has up here, I think that's FFOFF pink. We can just go ahead and get rid of this because I'm pretty sure that is behaving correctly now. We do still have one to, just eyeballing it at least, it looks like we do still have 1-to-1 on pixels. We have our one tongue pixel, it is floating a little bit, but that's just gonna be how it is, I think. Our eye is still 3 light pixels and a blue. We still have our little pink 1 pixel there on the neck. We have our single blue, we have our 2 blues, the next one, our 1 pink. Yeah, just rough eyeball, it looks like we're still 1-to-1 on all the pixels, which is good. That tells us, I think, that that second shear is likely to be correct. And that totally was our problem before, is we weren't covering up the original part. Okay. I think that I am about ready taking a break though. So I don't think I'm gonna do the last horizontal shear right now. Because basically I'm anticipating similar kind of problems that we had with this one. And I don't think I got the juice to work through them right now. So I think I will stop here. Thanks for hanging out. Thanks, DJ Devin. Hope you have a good rest of your day and weekend. I should be back next week at the normal time, Saturday morning, 10 a.m. Central Time. I'll be here working on some more CircuitPython stuff. Yeah, I think that's it for now. Have a good day. Have a good week. I will catch you later.